All right, good day, everyone. Welcome to my YouTube channel, and thank you for your support so far. I do not take them for granted. I really appreciate them. So, today, from chemistry, we'll be talking about nucleophiles and electrophiles. Nucleophiles and electrophiles. So, first off, I will pick nucleophiles and explain to us what nucleophiles are. Nucleophiles are atoms or groups of atoms or group of atoms with a negative charge or a lone pair of electrons. So nucleophiles are atoms, any atom that you have, or group of atoms with a negative charge or lone pair of electrons. They are called nucleus-loving species, hence where they got their name from, nucleophiles. So they loved nucleus, and we all know that nucleus is positively charged. So anything that would like this positive charge has to be negative. So that's why we say that nucleophiles are atoms or group of atoms with a negative charge. So the fact that they have negative charge makes them love nucleus that has a positive charge. I hope that we are following. All right, so they are nucleus loving because they say like charges attract. It's not the case, you know. Okay, unlike charges attract, yeah, it's the case. Unlike charges attract. So if we have positive and negative, they would attract each other. So the fact that nucleophiles are negatively charged makes them attracted to nucleus, which is positive charge. So examples of nucleophiles are NH3. Ammonia has a nitrogen atom that has lone pair of electrons. So this ammonia has lone pair of electrons, and so because of this presence of lone pair electrons here that we talked about, it makes it qualified to be called a nucleophile, and so it will love anything that is positively charged. So that's ammonia. Also, we have further examples of water. Water also has oxygen atom that has a lone pair of electron, and this makes it also a nucleophile because it loves positive charges, e.g. nucleus. Also, we have OH minus. This oxygen also carries a negative charge. It carries a negative charge, making it qualified to be called a nucleophile. Also, another example is represented by X minus, and they are called the halides. The examples include chlorine, fluorine, bromine, and iodine. So all of them, they carry negative charges, and they are called nucleophiles. So they are all nucleus loving. So now we would move to electrophiles. So electrophiles are atoms or group of atoms with a positive charge, or yeah, with a positive charge basically, and they are they are electron loving. So they are called electron loving species. They are electron loving. So that's what electrophiles are. Unlike the nucleophiles, they are positively charged. So they carry positive charges, and like I explained earlier, unlike charges will attract. So they would love um anything that is negatively charged. and that's why we say they are electron loving. So whatever it is that carries electrons, electrophiles are drawn to them, and that's where they got their name electrophiles from. So we'll move to the examples of electrophiles. We have NO2, we have NO2, we have H3O plus. This is positively charged, so it will be attracted to electrons, hence it is called an electrophile. We have Rn2 plus, where R is an alkyl group that we've explained in previous videos. You can do well to check them out if you are still confused. All right, so this is also an electrophile. Lastly, we have R plus. We have several other examples. I just gave us these few, you know, to explain. All right, so R plus meaning that alkyl radical, alkyl, an alkyl that is having a positive charge. It's not an alkyl radical. A radical will have dots, like we explained in homolytic and heterolytic fission. You can do well to check that out too. Alright, so basically the differences between nucleophiles and electrophiles is that for nucleophiles, nucleophiles are negatively charged and they are nucleus-loving species. And these are the examples. Electrophiles are positively charged and they are electron-loving species. And these are their examples. Alright, I hope that this video was helpful again. If you have questions, do well to drop them in the comment section. If you have observation, anything, do well to drop them in the comment section. If you have any topic that is bothering you in chemistry and you need help with it, let us know and we'll address them.